Here are solutions to homework set number 5 for ECE 476, Advanced Embedded. This homework set looks at using the graphics screen, the touch screen, and analog motor outputs for the Raspberry Pi-Pico. So here I've got a touch screen. I can sit there and adjust the speed with a touch screen. I've got a slew rate limit in the program to keep the noise down a little bit. Make the motor go forward and backwards, controlled through the touchscreen. So to do that, we did this in a couple steps. The first part of the homework is to connect the motor to your Pico through an H-bridge and verify I can make the motor go forward, stop, and backwards. So if I just kind of hard code it, say I want to output 100%, I can measure the voltage at 100%. I can measure the voltage at minus 100% and 0%. And here's what I got with the voltmeter. I've got 5 volts driving it. The H-bridge loses some voltage, so I wind up with only 2.67 volts across the motor at full speed. Next, come up with software that lets you control the motor through the analog input. This uses the graphics display to show the motor speed. I can use the joystick to adjust it up and down. And to do that, I use the following code. I set up the pin 16, 17 analog inputs. Those also show up as little lights down here. So this is reverse, forward. You see the different lights turning on and off. Also displayed on the graphics display. Turn on the graphics display, draw a box, label it, read the analog inputs, X and Y, only use X, or Y that is. Integrate for percentages, clipping it plus minus 100%. And if percentage is positive, I will output 0 to 65,000, 100% is 65,000. Backwards, I'll do the other pin that sets the speed on the H-bridge, display it as a line graph, and again, here's what that looks like. If I go centered, it is no change. If I go negative, I pull it down and then stop at some spot. That will set the voltage to the H-bridge that then sets the speed of the motor. To verify it, measure the voltage going to the motor versus percent duty cycle. And here's the data I got at minus 100% through plus 100%. If you plot it, you can see that this really should be linear. It's not. I suspect the motor is drawing quite a bit of current, which makes it nonlinear. Anyway, that's the data. That's the first part. The second part uses the touchscreen. So with the touchscreen, I am going to initialize the touchscreen, read the 0 position. Actually, don't use this anymore. Replace the analog input with the touch input. So I'm going to touch the screen, measure the touch input relative to the center position right here. If it's to the right of it, I will interpret that as my reference is to the right, left is negative, specify where it's supposed to be, throw in a slew rate limit, and output the pulse width based upon where the output is. So again, what that looks like, set this to be my input. It'll slew over there, so slew rate limit. As I move the touchscreen around, I can make the motor go forward, backwards, following the voltage on the touchscreen. And that is homework set number 5 For ECE476, with the graphics display, I can display information like bar graphs, numbers. I can use the touchscreen to input binary analog data, in this case it's analog, and use the analog outputs to control things like the speed of a DC motor. Homework set number 5.